Okay, so, first comment, a lot of you need to sign up for courses for next year. Next to Roxana on the board, I've listed the choices that you have. If you're IB, you need to take some kind of IB math class, if you're full IB. So there's SL and HL. The majority of people that are in BC Calc take HL. You don't have to if you have enough HLs in other courses, you can take SL. SL would be really easy. And there's AP Stats, which is a good course to have in college before going to college. I had mine in college taught by someone whose first language was English, but I couldn't understand. She said a lot of the beauty of is I heard every noun or preposition and verb, but not a single noun in the whole semester of the class. Drove me nuts, had to learn from the book, and I hate that. So I forever hate stats, but I use stats. Like they're always like telling us to look at the data, check the data. Then there's two flavors of multivariable. You can take multivariable at BCC, which is one regular class period in the day. And then there's multivariable through Montgomery College. They come here. So the class is at BCC, so you don't need to commute. However, it's 2 periods at the end of the day, and it runs on Montgomery College schedule, not BCC schedule. So there are days that we might have off that Montgomery College does not. And I don't remember if it's 2 days a week or 3 days a week. I think it's 3. And do you know what?
Hers is 3 now, but next semester's 2.
Okay.
Multivariable was 3, I guess. Yeah.
Okay, so multivariable is 3 times a week, period 6 and 7. Those of you who want to do an internship or something that necessarily messes that up.
How do you choose whether to do it through BCC?
There's a box on the sign-up form. I don't know, but there's two ways you can do multivariable. The multivariable at BCC, they get through what they get through, and then you take it again in college. Like you will not get college credit with the exposure that you have from the BCC class. My daughter took it and said by October 1st, they had covered everything that they did the whole year here at BCC, and then things were new. Montgomery College in one semester, they do Calc 3, and they get college credit for it. And it's a real course. It's hard. Any comments that you can say about Anna's?
She enjoys it.
She enjoys, maybe
she was
now
more
a little
emotional about this class than she was about multivariable.
Okay. Well, she enjoys multivariable, and there was a time that it was past tense. She enjoyed it, and then it was like not so fun. She dropped some nasty words about it, but she might be liking it again. And then there's always the option of independent study that you can do an online course through any college. It's there. I used to have students do this pre-COVID, so it's not a new thing. And I had kids taking Stanford classes. They'd sit in my class and do their online thing and go about their day. So there's that. And then if you want very low stress, there's honors stats. There are other fluffy nonsense math courses that you can sign up for, but it is not traditional that BC kids would go to, BC Calc kids would go to like financial literacy or something. But that is an option as well. So if you have questions, I don't know a lot more about any of those things than that, and where you go from here, it's all dependent on what you want to do after this. The majority of people that are in BC Calc tend to be STEM students. I had one that left and went to be a professional ballerina, and she still is. So anyway, there's that. Today is just this worksheet. I'd like you guys to try it with the people around you. This first one says quick calculator. Did you get a worksheet with that? So, work on it on your own and we'll go over stuff when you have questions.
I thought it was like that thing that we did yesterday, which is odd.
All right, guys, can we go over question 1 to make sure that we're figuring things out? 1A says write the equation of the tangent line of f at x equals 3. So we have the coordinate. They gave us the coordinate 3, 6 on the calculator because I'm not expecting you to do this on your own. F prime of 3, they gave you the equation of the slope. Plug in 3 and get a decimal. So y minus the y value equals slope times x minus the x value. Plugging in 3.1 for x, we get 6.234. Good? Tangent line. Strictly tangent line. Part B, doing Euler's method. Here's our table. And I ask that you put in the column dx, which doesn't change. Dx is 0.05. And I ask that you put that in there so that you know that it's multiplying these two to get that change in y. But doing 2 steps in Euler's method, we get 6.236. Okay, so then it says part 2 of this, which this is a free response question from AP. Part 2 says use the double derivative to explain why this approximation is less than f of 3.1. First of all, a lot of you missed questions, like the second part of the question, because you didn't read the whole thing. Like, I did Euler's method, I got an answer, moving on. There's a second piece. So using second derivative,
Okay, I did the second derivative and it wasn't negative.
okay, well, one thing, it's quotient rule and it's old.
Didn't quotient.
Okay, well, let's check. Bottom times the derivative of the top.
Bad.
What's the derivative of 1 plus e to the x? Just e to the x. Minus e to the x times the derivative of the bottom.
Wait, no, 1 plus ex.
Top times the derivative of the bottom, yep. Okay.
Then you plug in 3. No, wait, no, wait. X power of 4 is the denominator.
And bottom squared.
Now you plug in 3.
Yep.
And I plugged in 3 and I didn't get a negative answer. No.
So double derivative evaluated there. Let's check.
Oh, my calculator.
Okay, so parentheses, 3 squared times e to the third. Ooh, that's an S. E to the third minus parentheses 1 plus e to the third times 2 times 3. Close the parentheses up top, divided by so double derivative, I get 0.6 something, I get a positive number.
Exactly.
Okay, so that means what is the concavity, Amir?
Yeah, it's up. It's concave up.
So where does the tangent line sit?
tangent line sits below.
The tangent line sits below, so is my approximation for part A and part B, are they over or under approximation?
Under.
Under approximation. Sydney?
So when you do the, you have to choose three, would you plug in three or three?
Plug in the 3. And plug in the one they gave you. Just leaving it at that. Okay. So Amir, it says we should have proven that it was an under approximation,
right.
did we?
Yeah, we did.
Okay, perfect. All right, so part C, on the calculator, integrate this from 3 to 3.1, I get 0.238. What the heck? That is nowhere near these values. What is going wrong?
Well, you simply subtracted f of 3 by the f of 3 from f of 3.1.
So how do I get the right answer?
Well, you use the y-tick values in this table. Well, alongside, the
Okay, hold on.
integral.
So Cecilia?
Do you add it to the 6 because like it's from 3 to 3.1, so, and that's how much the function increased by?
So the 3.1, integrating 3 to 3.1 is how much did the y value increase or decrease in that amount of time? So exactly what Cecilia said, and I think what Amir was getting to as well, you need to add it to where you started. At 3, we were in position 6. We gained 0.238 more. So the actual value there is 6.238. And part of the point of this question was for you to see, okay, with just a single tangent line, so Euler's method of one step, we got 6.234. Euler's method, we got 6.236. And the actual integration, we got 6.238. So we got a little bit more accurate each time. And depending on the context of what you're using this stuff for, like if it's microsurgery, nanosurgery on like brain surgery or things on your spine, so every 1,000th of a micron off, you might be paralyzed. You want them to be super, super, super careful. So is it, what's good enough? Depends on what you're using it for. Okay, so keep working on the worksheet. Answers are posted. You can check the solutions online. Yeah, Sydney. Over and on the answer keys, if you look at the rubrics, if it's one of those complicated
Yeah, because that is just. Wait, I don't think she's. That's what number you got, because I wanted to. 2.467.
So this one, they're asking you, given the slope field, what's the solution that goes through 0, 1? So to me,
Yours is negative.
it's a 1.
Oh, and
There's
there's
two of them. There's two of them. It says,
Ours doesn't have that. Yeah. We just have one.
and then 0, -1 down here.
What number did you plug in?
So, and Rosanna, right, right here, I did it a little, like, I crossed over.
Yeah.
So it should be, it's kind of like if you're a leaf on the water, where you end up. And as long as you're not deliberately and blatantly crossing over,
Oh, that makes sense.
it's fine.
Did you look at the story?
Probably.
Yeah.
But again, last year, there was one of these on the AP exam and the graders were like, what the heck? But if it's a negative slope, you're making it positive.
They wouldn't. did you get one? I pressed
Okay.
derivative.
All right.
So.
Okay, guys, can we look at 2B? C, sorry. That's a hard question. And it was one of the more missed things. So you guys mentioned I had erased something from this. You said there's only one thing that they asked us to do. Part A asked for real to graph the line that goes through the coordinate 0, 1. And when I left that in, a lot of people said, well, shoot, the graph looks like it goes through 1, so I declare 1. Not incorrect, however, not an acceptable solution method. So how do we find what is this basically y-intercept of this straight line? Mary, you got an idea?
They don't. They never explain why. What is like? What's a human differential equation? It's like an equation.
Here is your given differential equation.
So like, what would be an S? What would count as a solution?
Okay, so what differential equations are here's all the slopes of this equation, like all the things that could be changing. And this one has x and y in it, which means depending on where you are on the graph, you're moving somewhere differently than if you're over here.
Okay.
I mean, you're a leaf in the water and there's rocks in the way and it makes eddies and curly Q things. So that was the point of part A, was if you were a leaf here, you're going to go along this nice straight line. If you were a leaf down here, you're going whoop, curvy. So this is the differential equation that we can't actually integrate. I cannot separate those variables and get the equation below. I just can't. Because this is a subtract. When I move something over, it's adding to the dy dx. All right. So this is saying this is a solution. How they got it, I don't know. But it says it is, like if I wasn't able to integrate. Yeah, so this is a solution. And by telling me that is a solution, it means that if I do the slope of this slope has to equal that slope.
Okay, yeah.
So if 2 equals 2y minus 4x, dividing everybody by 2, I get y equals 2x plus 1, which is exactly the form
Okay.
they were asking for. Hard question.
Okay.
Hey, Tom?
Do you have to like justify it exactly that way? Because like for C, so we know in part B that dy dx is always 2, so does it just say we recognize that the slope is 2? So, and we know that the initial condition given in part B was 0, 1, so it has to be 1. Or just like plug in the numbers we got in part B.
Well, no, because in part B, it is using exactly the coordinate that we're going through. In part B, if I gave you the coordinate 0, -1, your slope would not be always 2. So this one, often the AP question leads you through, but this one, they picked the answer. They picked the answer for you to graph it here. They picked the answer here to say, get the equation of the line, and you're right. Right there, the slope was always 2, but anywhere else, it's not. So that would not work for this one because they happen to give you the answer here, and here they're asking basically prove that's the answer. And I don't think that you can say, well, all the stuff I did in part B made it all work out. And it only worked out because they gave you it. They were working from their answer point already. So I would have to check the grading rubric for this, and it's so old, it's off. It's not available. Josh?
Can't we say though that like at the point 0, when x equals 0 and y equals 1, if we plug that into dy dx, we find the slope is 2 there. So we can say, then like, you plug in y equals 1 and x equals 0, and you get that b equals 1. So when does that work?
Are those the only numbers that work to give that thing a 2?
There are other numbers, but they also give b equals 1.
There are others, x and y values that make that the slope be 2 and forces b to be 1?
Like, that we found in the table we made in part B.
And I'm kind of thinking I could probably come up with a counterexample that would make it not be 1. Like, I mean, right here, that looks also like the slope is really close to 2. So I don't know. I don't think the example is that. But I don't know.
Which would just be 2 minus 4, which makes no sense.
Other questions on this one?
Which actually would just be minutes. Can we do this one?
D?
If the first two, there's just a lot of words that.
Yeah, there's a lot of words. I agree with you. Ooh, I love this one. Okay. G is the function that goes through 0, 0. And you cannot say, well, it looks like a maximum from the graph. How do we prove something has a max or a min?
Well, you need to find the second derivative.
Okay, first of all, for it to have a max or a min, it needs to be a critical point. Is it a critical point?
Well, if we judge by, you know, the differential equation, and if we plug both those values in, we get 0.
So it is a critical
Yes.
point. So how do I figure out if it is a maximum or a minimum? So normally I would look at the slope to the left and the slope to the right, but the slope changes depending on my x and my y value. Too many options to choose. You only have one way to go here. What do I have to do?
Do the second derivative.
Do the second derivative. Perfect. Okay. So the derivative of 2y is 2 dy dx minus 4 dx, which is 1. This second derivative at the coordinate we are talking about, well, this slope was 0. So 2 times 0 minus 4 is negative. So Gus, what's the concavity? It's concave down. So is this a maximum or neither? It's a maximum. The only place that it can be concave down with a slope of 0 is going to be that maximum. This is their way, like, this is second derivative test, and a lot of you only do the first derivative test, find where the critical points are, check to the left, check to the right. It went from positive to negative over that critical point, so it was going up, and then it became negative and started going down, so it's a maximum. This is their way of forcing you to use the double derivative. And real quick, can we look at this guy? Can we look at part B? It says, how come this can't be a solution? And we should have drawn the slope field. But look at the equation of the slope. dy dx equals x times y minus 1 squared. Why is this absolutely definitely not an answer? None other than Amir who knows it. Okay. Looking at the equation, dy dx, the slope is x times y minus 1 squared. Are there any, Claire, what do you see?
Because it passes through 1, 1, and that would make it 0. The slope's not 0 there.
At y equals 1, the slope needed to be 0, so not going to happen. Right? So if you didn't finish the worksheet, finish it and check the solutions that are posted online.
Okay, thank you.